Now I would like to discuss another problem here. A gambler has 2 rupees. He bets 1 rupees at a time and wins 1 rupees with the probability half. That means winning probability is half. He stops playing if he loses 2 rupees. That means after losing 2 rupees, he will have 0 rupees or wins 4 rupees. That means if he will have 6 rupees, then he will stop the, in both the case, he will stop the games. Either he will lose 2 rupees or he will gain 4 rupees. What is the TPM of the related markup chain? And what is the probability that he has lost his money at the end of 5 plays? What is the probability that the game lasts more than 7 plays? So let us solve this one. In order to solve this one, let us find the state space. What are the state space? So here we can say let xn denote the amount with the player at the end of at the end of at the end of nth round and of play. Okay. So if xn denotes the amount with the player at the end of nth round of the play, then the state space will be state space will be nothing but what will be the state space? If he lose 2 rupees, he will stop the play and he will gain 6 rupees. He will stop the play. In between, he will play the game if he has 1 rupees, 2 rupees, 3 rupees, 4 rupees, 5 rupees, and he gains 6 total, then he will stop. And if he lost all the 2 rupees, he will stop the play. So these are the state variables. These are the states. These are the states. Okay. At the game ends, if so, here we see that we have known that the play stops if he loses 2 rupees. That means xn equal to 0 and he wins 4 rupees. That is xn equal to 6. Already he had 2 rupees and he win 4 rupees. So total, if he has 6 rupees, if he have got 6 rupees, he will stop the play. And if he have got 0 rupees, he will stop the play. So now let us go for the first problem, how to find the TPM. How to find the TPM. So here there are 6 steps 0, 1, 2, 3, 4, 5, 6. So we will have the TPM is a stochastic matrix which is of order 6 cross 6. So the present states are here 0, 1, 2, 3, 4, 5, 6. These are my present states. This is I can say x n minus 1 and my future states are 0, 1, 2, 3, 4, 5 and 6. These are my future states. So 7 for 7 minus 1. So now I will denote it as xn. I will denote it as xn and I will denote it as xn minus present state and this one will be my future state. So now when he will have 0 rupees, so he cannot bet anything. So there is no possibility of gaining 1 rupees, 2 rupees, anything. So what will happen here when he will have 0 rupees? He cannot bet anything, so there is no chance of winning or losing anything. So these things will be 0. But from the stochastic property of the TPM, The sum of the elements in the row should be 1. So if he has 0 means he will not gain anything, that is confirmed. So that is 1. Now suppose he has 1 rupees, then what will happen? He may lose 1 rupees and he will have 0 rupees. So the probability will be 1 by, so 1 rupees, we 1 rupees, so that they means he is not playing the mat or game. And then if he has 1 rupees, he will bet 1 rupees means he may get 2 rupees. And other things will be G. Other things will be G. Okay. Similarly, when he will have 2 rupees, direct he cannot lose 2 rupees at a time, so he will not get 0 rupees. So this probability will be 0. And if he has 2 rupees, he can lose 1 rupees to reach to 1. And so here I can have 1 by 2. And 2 rupees and 2 rupees means he will not lose or gain anything. So if he has 2 rupees, he can gain 1 rupees to reach to 3 rupees. And so I will have this one. And other things will be 0. Other things will be 0. If he has 3 rupees, he never lose 3 rupees at a time to reach to 0. If at 3 rupees, he never lose 2 rupees to get to 1. That would be 0. And if at 3 rupees, he can lose 1 rupees to reach to 2. So this probability is 0. And 3 rupees, future present is 3, future is 3 means there is no play. And then he can gain 1 rupees to reach 4 rupees. So this will be half, because we have winning probability is half. If winning probability is half, then losing probability will be also half. Okay. Similarly, here what will happen? 0, 0, 0. So presently he is having 4 rupees. He can lose 1 rupees to reach to 3. So I will have 1 by 2. Present 4, future 4 is play is not there, and he can gain 1 rupees to reach to 5. So this will be the thing. Then 5 rupees means this is 0, this is 0, this is also 0, and this is also 0. He can lose 1 rupees to reach 4, and 5, 5, and then this one will be the thing. Now suppose he is having 6 rupees, this is 0, this is 0, this is 0, this is 0. He cannot lose 2 rupees at a time and reach to 4, so this would be 0. But only one possibility is 6 means he cannot stop the play. And so what will happen? He only one chance is there. He has to lose 1 rupees, and that is here. That is here. So this is our TP. This is our TP. Okay. Now what we will do, next question is, what is the probability that the man will lose the money at the end of live play? So we can say x5 will be end of 5 play, means we can say x5 equal to probability of x5 equal to 0. So in order to find x5 equal to 0, let us find the initial probability. What will be my initial probability? From the question you see that the man can start the play if he has 2 rupees. He has 2 rupees. So depending upon that, I can have my P0. I can have my P0 is, if he will have, if he has 0 rupees, he cannot start the game play. If he has 1 rupees, he cannot start the play. So now he has 2 rupees, then only we can start the play. So initial probability will be, this. Okay. So now what I want to do is, in order to find probability x5 equal to 0, that means the player will lose all monies after 5 play. What I will do, I will find first P1. P1 means P0 into P. Capital P is this one, P0 already you know it. And so that if you find the product of these two, what you will get, 0, half, 0, half, and then 0, 0. This will be your P1. Similarly, you can find P2. P2 will be nothing but P1 into the TPM P. P1 into the TPM P. And if you do this one, what you will get here is, if you find P1 and P, find the product of P1 with P. P1 is this one and P is this. And if you get the find product, you will get, what you will get, 1 by 4, 0, 1 by 2, 0, 1 by 4, 1 by 4, and 0. This will be the second step, probability distribution. Then I will find, since I am going to find the fifth step after fifth play, so I have to find that up to P5. But what I will do here, P3 next I will find. P3 means P2 into capital P, and that will give me, what will be the thing, 1 by 4, 1 by 4, 1 by 4, 0, 3 by 8, 0, 1 by 8, and then 0. This will be my P3. Then I will find P4. So what will be my P4? What will be my P4? P4 will be P3 into capital P. And so that will be nothing but 3 by 8. That will be nothing but 3 by 8, 0, 0, 5 by 16, 5 by 16, 0, 1 by 4, 0, 1 by 16. So this one will be my P4. Then let me find the P5. P5. P5 is nothing but P4 into capital P. And so that will give me 3 by 8, 3 by 8, 5 by 32, 5 by 32, 0, 9 by 32, and 0, 1 by 8, and then 1 by 16. This is my P5. And then let me find P6. P6 will be nothing but P5 into capital P. So that will give me 29 by 64 and 0, 7 by 32, 0, 13 by 64, 64, 0, 1 by 8. And let me find P7. P7 is nothing but P6 into capital P, and that will be nothing but 29 by 64, 7 by 64, 0, 27 by 128, and 0, 13 by 128, and then 1 by 8. So this will be my P7. So next, what I want to find is, next what I want to find is probability x5 equal to 0, and that is nothing but probability the man lose or lose his money at the end of hit play. This is the thing, and that is equivalent to after step 5 the initial the first one component p0 means first component, so this is equivalent to p0 p1 p2 p3 p4 like that. So first component in p5, first component in p5 is nothing but first component in P5 is nothing but probability x5 equal to 0 is nothing but 3 by. So this is my probability that the man will lose his money at the end of fifth play. Now let us go to the third question. What is the third question? What is the probability that the game lasts more than 7 plays? That means he is neither in the state 0 nor in the state x equal to 6. So what will be the thing? Third thing is probability the game lasts more than 7 plays, and that is equivalent to saying probability x7 after the end of seventh play he may have rupees 1, 2, 3, 4 or 5. He will not have 6 rupees, because if he will have 6 rupees then he will stop the play. So there is a possibility that he may have 1 rupees, he may have 2 rupees, he may have 3 rupees, he may have 4 rupees, or he may have 5 rupees. Then he will continue playing the game, and this is what we the probability will be. Because of this, what will be the probability? This will be nothing but x7 equal to 1. x7 means after 7 step x7 equal to 1 means p1, that will be 7 by 64 here. 7 by 64. So I will have here 7 by 64 plus 2 means I will have 0. So 0 plus 3 means I will have 27 by 128. So we can have 27 by 128, and 4 means I can have 0. So I will have 0, and 5 means I can have 13 by 128. So I can have 13 by 128. So if you take the sum of these, we will get 27 by 60. So this is the probability that the game may last more than 7 plays. Okay. Next, another example on the classification of the Markov chain. The question is like this: find the nature of the states of the Markov chain with the TPM. That means our state space are given 0, 1, 2, and the corresponding TPM is given like this. So we will decide whether the Markov chain is uh, periodic, aperiodic, ergodic, or non-null persistent. We have to decide. Okay, so now you see that this is our TPM, where this element is 0, this element is 0, this element is 0, this element is 0, this element is 0. So we will find P2. So if I consider this is my P1, then we will find P2. P2 means P into, and that will give me 1 by 2, 0, 1 by 2, and 0, 1, 0, and then 1 by 2, 0, and 1 by. So this will be my P2. This will be my P2. And similarly, let me find P3 also. Let me find P3. P3 will be nothing but P3 will be nothing but P into P2. And so that we will get as 0, 1, 0, 1 by 2, 0, 1 by 2, and then 0, 1. So if we find continuously, we will get P2 will be nothing but P4. P2 will be nothing but P4, P6, and so on so P to the power 2. And if we find continuously, we will find that P3 will be nothing but P7, P5 will be nothing but P7, and so on so we will have P2n plus 1. P2n plus 1. Okay. Now, if this is my thing, this is my TPM, which is of the form P00, P01, P02, and then P10, P11, P12, P20, P20, P21, and P22. If this is my TPM, here P00 in the initial TPM is 0, but you see that P00 in the step 2. So here we find that P00 in step 2 is positive. Okay. Similarly, here you see P12, P02 is 0, but P02 in second step. So here you can see P02 in second step. This is also positive. This is also positive. So here this will be equal to capital P, and this will be equal P square, and this will be equal to P. So this will be the thing we will observe. This is P2, and this will be the thing we will observe. PQ equal to P5 equal to P7 will be nothing but P. And so here we can see that each zero element in the initial TPM becoming non-zero in the second step. In the second step. And again, what we will say, so therefore, so here you can see one by one 9 element we will see. Already here we are having P00 in step 2 greater than 0, P01 greater than 0, and P02 in step 2 greater than 0. Similarly, P10, P10 already here greater than 0. So P10 is greater than 0. Now P11 in step 2 is greater than 0, is greater than 0. And we have P12 is greater than 0. Similarly, we can have P20. P20 initially it was 0, but in the second step it is non-zero. So in the second step we are going finding this is non-zero. And then in the P22, P22 is positive, and then we found that P22, P21, P22 in the second step is positive, and therefore the 9 components are positive after second step, and therefore we can conclude that the Markov chain is irreducible. Therefore, the Markov chain is irreducible. Markov chain is irreducible. Okay, and then we see that we see that PII in second step is equal to PII in fourth step is equal to PII in sixth step and so on. So PII in 12th step are all positive for for some n for some n and all I all states. Okay, and therefore what will happen, the diagonal elements are positive, then we will find di. Is the period, so that is nothing but gcd of 2 4 6 and so on, so 2n, and that will be okay. So here di equal to 2, which is greater than 1. Therefore, we can say that the state of the chain are periodic. Therefore, the Markov chain is periodic with period period 2. So it is irreducible and it is periodic. If it is irreducible and it is periodic, then we can say that it is non-null processing. Since the Markov chain is irreducible, and periodic, therefore it is non-null persistent. All states are are non-null persistent. Non-null persistent. Okay. If all states are non-null persistent, we can claim that not all of the states are ergodic. Therefore, hence, we conclude that all the states are not ergodic. All the states are not ergodic. Okay, so it is finite and irreducible. So it is non-null persistent, and if once it is non-null persistent means we can conclude that all the states are not ergodic.